Now I like to work through a few examples on using logarithms, so get used to the techniques, and don't forget logarithms are like indexes, so we're going to use some of that way of thinking to be able to do these. So we've got x equals log of 10 to base 2 plus log 12 to base 2 minus log 15 to base 2. And we're asked to find x. This is a straight application of the first and second properties which we've done. So we're adding logs, which means we are multiplying the numbers. So when you add logs, you multiply the numbers, 10 times 12. When we're subtracting logs, we're actually dividing that number. So using the first two properties, we've got log to base 2 of 10 times 12, which is 120 over 15, which is the log of 120 divided by 15 is 8, so log to base 2 of 8. Now from that you can either use your own idea that, okay, log, what is the power? You've got to raise 2 to get the number 8, 2 to the power of 2 is 4, 2 to the power of 3 is 8, so answer 3. Or another way of looking at it, it's equal to the log of 2. Now because we're at a base here, we can raise 2 to the power of 3, 8 is 2 to the power of 3. Using one of the other properties we've just done, that 3 can come out the front, so that'll be 3 log 2 to base 2. And the log of 2 to base 2, what's the power we've got to raise 2 to get the number 2? 1. So log 2 to base 2 is 1, so that's 3 times 1, which is equal to 3. Same answers if we can work out the other way as well. Okay, number 2, we've got log of x to base 5 equals -3, and we've got to actually find the value x. We go back to our definition. We can say that x, from the definition, if log of x to base 5 is equal to -3, then x equals 5 to the power of -3. Just using the, this is like the second line of the definition I gave you, and you're going back to the first line. So if we've got that, raised to the power of -3 is over 5 to the power of the positive 3, and 5 squared is 25, 5 cubed 125, so x will be equal to 1 over 125. 3, if we've got 2 log 2 to base e plus log x to base e equals log 3 to base e, and we've got to find x. Your general strategy for solving equations is to get the term containing the unknown by itself. In this case, we've got log x to base e is equal to, and bring this over the other side, so this one will stay where it is, log 3 to base e minus, now instead of writing it that way, we can use one of the properties here to put the 2 up the top, so that'll be log base e of 2, and that power of 2 comes up there now. And when you're subtracting logs, you are dividing. So 2 to the power of 2 is 4, so that'll be 3 over 2 to the power. So we've got log x to base e. Now when we've got single log equals single log, we can take away the logs, and we'll just get x equals 3 over 4. So it must be single log, single log. If that's the case, then what comes after the logs must be the same. Okay, just like if you divide both sides by 6, if you've taken logs, well, you take away the logs of both sides and you get x equals 3 over 4. So that's number 3. Number 4, we're asked to solve for x, and we've got 3 to the x minus 1 equals 2 to the x. Now once again, we've got the unknown on both sides. We can't get all the x's to one side. We can get those two together. We can take the 2 to the x. That's probably not going to get us too far. A general strategy for finding an unknown when the unknown is in the powers is to take logs. Now we can take logs to any base, but we'll take log to base 10. Now if it is to base 10, you don't have to write the number 10 down there. If the word log is there without a base, it is assumed to be base 10. So I'm going to take log to base 10 on both sides. So log of 3 to the x minus 1 equals log of 2 to the x. Now once again, our properties means if you've got a power with the number here, the power can come out the front. So you've got x minus 1 log of 3 equals x log of 2. I'll remove the brackets and I've got x log 3 minus log 3. So multiplying, if you like, the log 3 times x, and you get x log 3, and then the log 3 times 1, you get that, equals x log of 2. Now I want to get the terms containing x by themselves. I'll bring this over to that side, and I get x log 3, which is already there. Bring this over, minus x log 2. Now if I'm getting the terms containing x on the left, I want the numbers on the right, so I'll take the minus log 3 to the other side. Take this here, other side, it'll become log 3. I can now factorise and take x outside of log 3 minus log 2 equals log 3. And I can divide both sides by this bracket here. And if I do that, I'll get my x by itself. And my denominator will be log 3 minus log 2. Now, don't forget that you could probably express this if you're subtracting logs, you're actually dividing the numbers. So that'll be log of 3 over 2, and that'll be log of 3. And if you use your calculator with log to base 10, which is just log, you can find the log of 3 divided by the log of 1.5, and you'll get 2.7093. Normally when working with logarithms, if we're going to give an answer, we use 4 decimal places. So when dealing with logarithms, just for accuracy. So there's 4 examples of using logarithms to solve. Done a straightforward one there with a couple of properties. This one's just using the definition of a logarithm. And then we finished with 2 more when we've actually got equations. And if you've got the unknown as a power, it is just a normal strategy. Take logs of both sides.